Hi, my name is Jess Cannon, and this is my presentation for Computational Thinking Final Project. Here is my abstraction. The dataset I chose to work with was from the Health Library. It is retrieved from the Corgis Dataset Project, and it shows reports of diseases in America by year, disease, and location. Some of the limitations I found was that this dataset can only answer questions about diseases in America, not other countries. The dataset also includes only the reported disease cases. Also, this includes only the diseases measles, smallpox, and polio. Here is my data structure map. As you will see in my coding work, there is a list that contains all the reports of diseases. Inside this list, there are many dictionaries. This data set had a lot of data, and there are about 1,000 entries. In each dictionary, there contains the properties disease, increase, location, number, population, and year, and then that particular value for the entry in the form of strings, floats, or integers. My first question I decided to ask was, how does population correlate with the number of disease cases? I wanted to see if the population was lower if the disease spread more easily. I decided to split this question into 3 separate codes and look at each disease, measles, smallpox, and polio, to see if there was a different correlation between each disease and the population. This is my first visualization for the case polio. Number stands for the number of cases found. As you can see, the number of cases is heavier as the population is lower, shown in the visualization. Here is the visualization for the measles. As you can see, this graph is a little bit more spread out than the polio graph, but there are the highest number of cases as the population is the lowest, but it continues to have many cases as population increases. This is the visualization for smallpox. This graph isn't as conclusive. It does have a high density of cases at low population, but is also spread out between different population amounts. My next question was to see the correlation between the increase of the disease, which means how much the disease increased in cases each year, and the population. I also split this question up into 3 pieces of code comparing each disease with the question. The same 3 diseases, measles, smallpox, and polio. This is the visualization for smallpox. This graph shows that there is the most number of cases when the increase was 0. This is the most cases when population is below 0.4 and a higher increase. This is the visualization for polio, and in this graph it shows that keeping the population relatively low and having an increase between 0 and 10 are the most cases of polio. Here is the visualization for the measles. It shows that keeping the population relatively low and having a higher increase gives the most cases of the disease. In conclusion, I found that population is the biggest factor on affecting the amount of cases of a disease, no matter what the disease is. This has a social implication that you are more likely to contract a disease if you are living in a smaller population. This is the end of my project, and thank you for watching.